So we're going to talk about linear functions. So what we were doing before was functions. Today we're going to start doing linear functions. What are linear functions is, linear function is, suppose we did something like this. So I'll write a definition here. A linear function is a function of the form fx is equal to mx plus b, where m is my slope and 0 comma b is my y-intercept. So the question you'll get on these kind of problems, linear functions, we did before also, but we're going to do more today, is, let's take one example first. Graphing. We did
0 or 0?
It's 0. It's 0b. This is b, okay, not 6. My b looks like 6. So this is b. Okay. Next thing, okay, examples of graphing. So it says graph the linear function. Okay, it says example fx is equal to negative 3x plus 7. Negative 3x plus 7. We did various ways to graph this already. We did by making the table. We did by plotting the y-intercept, then rise over run. We did various different methods. It's up to you which method you want to do. Let's do this with y-intercept and slope. With y-intercept and slope. Note my equation here. This equation is already in standard form. It's already in standard form. You're like, yeah, fx is basically y. So y is equal to negative 3x plus 7. It's the same thing. Fx basically means y. In this case, you have to tell me the slope and the y-intercept. Karen? Is Karen here?
Yeah.
Can you tell me what's the slope in this case? What's my m?
Minus 3.
Okay.
Negative.
Y-intercept? See,
I don't know.
compare here. Compare here. I say 0b is my y-intercept, right? What is my b?
Okay. X and 7.
What's my here? See, it's 0b. 0 will remain as it is. What's my b?
7.
So 0, 7 is my y-intercept.
Okay.
Perfect. So once you figure out your slope and y-intercept, start graphing. First, let's make the number line. 0, 7. So this is my, I said 1, 2, 3, 4, 5, 6, 7. This is my 1, 2, 3, 4, 5, 6, 7. Negative 1, negative 2, negative 3, negative 4, negative 5. Negative 2, negative 3, negative 4, negative 5. Okay. Was?
Yeah.
What's my first step?
Plotting the points.
Yes. So what's my first point?
0, 7.
Okay, I marked my 0, 7. 0, 7, that means 0 on x-axis, so I'm not moving on x-axis, and 7 units on y-axis. Next thing.
Then
Let's see, m is equal a slope, right? So remember your
yeah.
slope is always equal to m, which is always equal to rise over run.
Uh,
Run, right? In
yeah.
this case, your slope is -3. So how much is your rise? Was.
-3.
And how much is your run?
Oh, 1.
Yes, because it's over 1. If it's nothing, it's over 1. So rise
Yeah.
-3, run 1. Rise. When it's rise, do you go left, right, or up, down for rise?
Uh, Up, down.
Yes. Rise means you either you go up or you go down.
Mm-hmm.
For run you go left or right.
Right.
So -3. I'm gonna go upward or downward.
Downward.
Downward because it's negative. Yes. I go 3 units down. I reach 1, 2, 3. I reach this point here. From this point, I'm going to run towards right or left?
Uh, Left.
Right, because it's positive, right? So I have to go towards the positive
Right.
side. If it's negative, I'll go this side, but it's positive, I'm going to go this side. So I go this point. So I reach here. This is my first point. What about the next step?
Make a straight line.
I
Or
will,
not
but I
yet.
need one more point. I need one more point. Again, do the same step, rise over run. Now, this is your new point. From this point, what I'm going to do?
Go down 3 more.
Okay, go down 3 more
And go right 1.
go right 1. I reached this point. No, this is my graph. That's it. Join the line. That's your graph. You can keep on doing this. Go 3 down, 1 right, 3 down, 1 right. You can get so many points on the line. You can keep on doing that. But that's how your graph is going to look. Okay. What I want you to do is, I want everyone to graph. So everyone will graph right now. Graph fx is equal to 2x plus 3. I want everyone to graph this. Fx is equal to 2x plus 3. Do it right now. If you don't understand, ask me, I'll help you.
Do we need to find the x-intercept too?
No. I mean, that's another way of doing it. That's another way of doing it. What's the y-intercept in this case?
3?
0, 3.
0, 3.
Oh, yes.
So you're saying y-intercept is 0, 3. What's your x-intercept? Let's find your x-intercept. How do you do it?
You said x equal, or y equal to 0.
So it becomes 0 is equal to 2x plus 3. What's my x? Let's solve for x.
So we get -3 equals 2x.
Yeah. -3 is
Divide by 2.
right by 2. X becomes -1.5, right? So your basically x-intercept is -1.5, comma 0. Right? Another way of graphing is, let's point these through. Now you have your x-intercept, y-intercept. Just plot these. So 0, 3 is here, negative 1.5, 0 will be somewhere here, and join those lines. That's it. In this case, you don't have to even do rise over run. When you're doing y-intercept and x-intercept, you just need those 2 points, plot and join them. That's it. That's another way of graphing. Another way was we make this table xy. Take different values of x, plug in the equation and find different values of y. Plug in here those points and graph it. Anyone has any doubt with graphing so far? You should know these 3 methods. We have done. You should know all the 3 methods. Okay. Next today what we are doing is, so we did in the last lecture, average rate of change. Average rate of change. We did this before in the previous lecture. Shaira,
Yes.
can you tell me what was the formula for average rate of change?
Change of y over change of x.
Change in y over change in x. This was our formula we did last time. The formula for average rate of change. So basically your average in case of linear functions, in case of linear functions, average rate of change is actually equal to slope of the equation. It is equal to the slope of the equation. So if I say find the average rate of change or find the slope, it technically means the same for the linear function. Suppose you are given y is equal to, and remember the slope was, we wrote the slope formula as y is equal to y2 minus y1 over x2 minus x1. It's the same thing. See, I'm finding the change in y divided by change in x. So my formula remains still the same. My formula still remains the same.
Sorry, what comes after equal to in the
Slope of the equation.
okay, thank you.
Slope of the equation. This will still remain the same. So average rate of change and slope are technically the same, mean the same in case of linear functions. So let's do an example on this. It's like, does everyone have their books or no? Not yet. Who doesn't have their book?
I don't have anywhere to put it.
I don't.
Okay. And I'm going to show you here. Okay. Let's see here. Can you see problems 13 to 20 clearly? Can everyone see problems 13 to 20?
Yeah.
Okay.
Yeah.
Okay. Let's see. Can I have Samantha?
Yes.
Okay, Samantha. Can you tell me? So, see, let's see different parts we have to do for this question. Let's see the first part. It says, determine the slope and y-intercept of each function. Let's see the first one. So, you're given fx is equal to 2x plus 3. Let's see the first one. So, you're given fx is equal to 2x plus 3. I'm doing the 13th question. It wants me to find my slope and y-intercept. Can you tell me what's my slope and y-intercept?
The slope will be 2,
Yeah.
and the rise over run would be 2 up. and 1 down, and the y-intercept would be 0, 3.
Perfect. Perfect. Okay. Angel?
Yeah.
Okay. For the same problem, let's do the first one. Use the slope and y-intercept to graph the function. So we have to use, which we already did. They are different. So you have to use slope and y-intercept. Let's do it. So I'm going to graph here and you tell me how to go about it. I'll just mark randomly 1, 2, 3. Okay, you tell me, what's my first step?
So we can start at 0, 3 because that's our y-intercept.
Okay, I marked 0, 3, then?
And then we go up 2 to the right 1.
Okay, up to right 1. Okay, I reached here. What's my next step? I need one more point.
We do the same thing, up 2, right 1.
Okay, from the new point up to right 1. Perfect. And then you graph this. Join these lines. Perfect. Any problem with these two? How to graph slope and y-intercept? You should know how to graph slope and y-intercept. These are two important things. Okay. Next thing. Miguel? Miguel? Miguel is not here? Hugo?
Here.
Okay. Hugo, can you tell me how to do the third one? It says, determine the average rate of change of each function. What's the average rate of change for the 13th one?
I'm sorry, for which number?
For 13th question.
The 13th?
Yeah, 13th one.
Okay. So what's your question?
I'm C part. I'm asking the C part.
Determine the average rate of change?
Yes.
Well, it will be the slope.
Yes, exactly. So what's my answer?
It's 2 over 1.
Yes, 2 over 1. So basically the answer for my C part, average rate of change is equal to 2 over 1, or basically you can just write 2.
Okay.
Yeah, perfect. It was Hugo, right?
Yes.
Okay. Christopher?
Yes.
Okay.
Hello?
Next. Yeah. Okay. Okay. So similarly, we are going to do 14, 15, 16. I want everyone to try this. Actually, everyone try the 15th part. 15th. I want 15th and I want you to do A, B, C part, not the D part. I just want you to try A, B and C part for the 15th question. I want to see right now. I'll ask you to show on your screen your work. So make sure you do it. For 15th question. Giselle?
Yes, I'm still working on it. Give me a quick sec.
Perfect, no problem.
It was 14, right?
15.
15. Sorry about that.
If you're doing 14, it's okay. Show me 14.
Okay.
Whatever you're doing.
Quick sec. Just to confirm, is it 5x minus 4 or 3x minus 4?
It's 5x minus 4.
Okay.
Okay, you tell me what's the slope in this case.
The slope will be negative 4. Sorry, it will be 3.
Which one are you doing? 14th or 15th?
14.
Okay, what's my slope in this case?
It will be 3.
Why it will be 3?
Oh, 5. Sorry.
It's 5x minus 4, so my slope is 5.
Uh-huh.
And what's my y-intercept?
It's going to be 0, comma, negative 4.
Perfect. And how do you graph it?
You start at 0, negative 4.
And then
3 over 1.
5
To your
over,
right side?
5 over 1.
5 over 1, sorry.
So how much I'm going to rise or how much I'm going to run?
You're going to go up 5
Yeah.
and then move 1 to the side.
Okay, perfect. And then what's my average rate of change?
I don't know.
Average rate of change is basically my slope. So what's my slope in that case?
It would be 5.
Perfect. You got your answer.
Okay.
Average rate of change in case of linear means a slope. So it's the same thing. Any doubt with this
Okay.
problem? Any doubt with these problems? Okay. Next thing we're going to do is increasing, decreasing, and constant functions. Increasing, decreasing, and constant functions. How do you figure out whether my function is increasing or decreasing or constant functions? So write the definition. I'll give you the definition for this one. It says a linear function fx is equal to mx plus b is increasing over its domain if its slope m is positive. So that's one thing. If m is negative, it is decreasing. If m is equal to 0, it is constant. So basically a linear function will be given to you. What you have to check is the slope. If my slope is a positive value, then it's gonna be increasing. If it's a negative value, it's gonna be decreasing. If my slope is equal to 0, it's gonna be constant. So let's see problems on this. Example. Okay. I'll take fx is equal to 5x minus 2. Can I have Joshua?
Yep.
Okay, what's my slope in this case?
It would be 5.
Is it positive, negative, or constant? Oh, 0.
Positive.
Positive. If it's positive, it's increasing, decreasing, or constant?
Increasing.
Perfect. So my function is increasing since my slope is positive. Let's take one more example. You're given fx is equal to minus 2x plus 8. Erica? Erica? Not here. Gerald?
Yes.
Okay, Gerald.
Sorry.
It's okay. What's my slope in this case?
Your slope is -2.
Okay, -2. Is it positive or negative? Or
Negative.
Negative. So it's increasing.
Therefore, it's decreasing.
Perfect. Perfect, Ivan. Let's do one more example. You're given s of t is equal to 3 over 4t minus 4. Daniel? Daniel? He's not here. N1D? N1D?
Yes, yes.
Okay. Can you tell me what's the slope in this case?
3/4.
Okay. What is it? It's increasing, decreasing, or 0?
It's increasing
Why?
because it's not a 0 or it's not negative.
Yes, it's
a positive number.
Yes, perfect. Okay. Let's do one more example. I have h of z is equal to 7. Okay. Jessie? Jessie? She's not here. Jose?
Yeah.
Okay. H of z is equal to 7. What is it? What's my m?
You don't have a slope, so it's constant.
Yeah. If it's not there, there is no x term. So basically there is, but there is 0 times m, 0 times x. There is something known as 0 times x. So in this case, my m is 0. When there is no x term, that means my m is actually equal to 0. So that means it is a constant function. It is a constant function. Any doubt with how to find out whether it's positive, whether it's increasing, decreasing, or constant? Okay. Everyone got this? If you have your books, I want you to go to page number 137. Page 137. If you have your books. And from questions 13 to 20, you are going to tell me whether it's the D part I want, increasing, decreasing, or constant. From 13 to 20, just tell me whether it's increasing, decreasing, or constant. Alejandro?
Yes.
Okay, first part. What's my slope?
Sorry.
For the 13th part, what's my slope?
For number 13.
Yeah. Slope is?
2 over 1.
2 or 1. Is it increasing, decreasing, or constant?
It's increasing.
Perfect. Okay. Giselle? Giselle?
Yes. Yes.
Can you tell me the 14th one? What's my slope?
And what number, excuse me?
14th.
14. The slope,
Yeah.
it would be 5.
Okay. Is it increasing, decreasing, or constant?
Increasing.
It is increasing. Perfect. Okay. Can I have Axel? Axel?
Yes.
Okay. Can you tell me the 15th one? What's my slope?
-3.
And is it,
3 and it's negative.
yeah, okay. And what is it increasing, decreasing, or constant?
Decreasing by 3.
Perfect. Jelena? Jelena? She's not here. Carly?
Yes.
Okay. Can you tell me the 16th one?
16th, the slope would be -1.
Okay, and what is it increasing, decreasing, or constant?
Decreasing.
Perfect. Five is here. Eduardo?
Yeah,
Okay, the 17th one.
17, it's gonna be it's gonna be increasing.
17. Okay, what's my slope?
Oh, repeat that again.
What's my slope?
Your slope is gonna be 1 over 4x. So the rise is gonna be 1 and the run is gonna be 4.
Yes, perfect.
Still gonna be increasing because the numerator isn't negative.
Okay, perfect. Yes. The thing is, you check this. Whenever I ask you slope, you don't put x. The slope will be just 1 over 4. Okay, not 1 over 4x.
Yeah.
Okay, perfect. Hawking.
Yes.
Okay, can you tell me the 18th one?
18th, I have it decreasing with the slope of -2/3.
Yes, perfect. Nicholas. Is Nicholas here? Can I have Daniel? Karen?
Yeah.
19th one.
We have no slope.
Okay, which means my slope is 0.
0.
Okay, and it is a
Constant.
function. Perfect. Okay. Erica? Daniel is not here. Jesse? Okay. Axel?
Yes.
The last one.
See, it's -2.
What's my slope is?
It has no slope.
No slope, and that means my function is?
Neither. Is that increasing or decreasing?
What is it?
I forgot the third option. But it's not increasing or decreasing.
Constant, constant.
Constant. Thank you.
Constant, yes. Any doubt with these problems? Any doubt with 13 to 20? These parts here. Slope, y-intercept. This thing in these examples, my equation is in standard form. If my equation is not in the standard form, make sure you put in the standard form first. And then answer these problems. Here in the questions, they already put in the standard form. Okay. Next thing, okay, let's see. Other part here. Next, let's see here. They say you have, let's see these problems here. You have to determine whether these functions are linear or not. Whether they say you have to figure out whether these functions are linear or not. And if they are linear, they want you to find the equation of the line. Okay. So I again repeat the question. So you are given this here. You are given various points on the line. They are saying this -2, 4 also lies on the line. -1, 1 also lies on the line. 0, -2 also lies on the line. 1, -5, 2, -8. These all lie on the line. They all lie on the line. They want you to check whether this thing is linear or not. They want you to check whether this thing is linear or not. If it's, linear, they want you to find the equation. How to do these kind of problems. I'll show you. So I'm going to write it here. So I'm going to do the 21st part here. I'm going to do the 21st part here. I'm on page 137. If you don't know, I'm on page 137. Okay. So it says x and you're given y values. You're given x and y values. You're given -2, 4, then you're given -1, 1, 0, -2, then you're given 1, -5, 2, -8. You're given these values. They want you to check whether this thing is a linear function or not. Okay, they want you to check whether it's linear function or not. Take any 2 points. Take any 2 points first. I take this one and I take this one. So I write it like this. So my first point I'm taking is -2, 4. And the second point I'm taking is -1, 1. I'm taking these 2 points. Okay. Let's see. Can I have Eduardo?
Yeah.
Okay. I have these 2 points. I need to find my slope, m. What's the formula for slope?
For the slope, it's going to be fx equals
Slope. I'm given 2 points now. I'm given 2 points. I need to find the slope.
yeah fx equals negative 3x.
How did you find negative 3x?
Because looking at the table we have, does x and y 0? We know that our starting point is going to be at negative 2 for our y-axis. So if we're going to go up 1, it's going to have a major difference, showing that it's going to be going down by 5, by 3.
Forget about this thing. I want you to find the slope. You're given 2 points. I want you to find the slope. How do you do it?
If you're going to give it just only those two points, we'll just draw it out.
No, how do you check it? Is a formula. Remember we did y2 minus y1 over x2 minus x1. You're going to use this formula. Change in y over change in x. You're going to use this formula. Whenever you're given just 2 points, you're going to use this thing formula. Change in y over change in x. Okay. In this case now, Eduardo, you tell me what's my y2?
Y is going to be 1 minus 4.
1 minus 4 over
negative 1 minus negative 2.
Yes. So what does it become?
The same answer you did the first time, I think.
Yeah, so what do you get in? Can you solve for me? Eduardo?
It's going to be negative 3 over
1 plus, negative 1 plus 2, which is negative 3 over
1.
Which is negative 3. So with these 2 points, when I use these 2 points, I'm getting my slope as negative 3. Write it like this. So this is my slope. Take any other point. Take any other point too. First we took this point and this point. Now let's take, I'm going to take negative 1, 1, and the other point I'm going to take is 0, negative 2. Pick other 2 points. And check for the slope. Check for the slope again. M is equal to, again, y2 minus y1 over x2 minus x1. Can I have Hawking?
Yes.
Okay, can you tell me how to do this? What's my y2?
Negative 2.
Negative 2 minus
1.
Over x2 is
0.
Minus
1. Negative 1, sorry.
Negative 1. So what does it become?
So we're going to get negative 3.
Over?
Negative 1.
Negative 1? Negative makes it positive.
Oh yeah, sorry. So 3 over 1.
Negative 3 over 1. So basically with these 2 points, I'm getting also negative 3.
Got it.
Yeah, perfect. Similarly, you check for these 2 points. Similarly, check for 0, negative 2, 1, negative 5. Check for these 2 points also. Again, the formula is equal to y2 minus y1 over x2 minus x1. Carly?
Yeah.
Can you tell me what is y2 minus y1?
Negative 5 minus negative 2.
Over?
1 minus 0.
So what does it become?
Negative 3 over 1.
Negative 3 over 1. So basically these points also negative 3. And you can check for other point also, you're still gonna get negative 3. No matter what points I'm taking, my slope still remains the same. If your slope still remains the same, that means this is my linear function. Linear function. So these points are of a linear function. Note here, you can back it if slope is same for all points. Slope is same for all points. Okay. Jalina? Is Jelena here? No. Giselle?
Yes.
Now they want you to find the equation of the linear function. What's the equation of the linear function?
The equation of the linear function is fx equals mx plus b.
Yeah, mx plus b. This thing is known as slope-intercept form. Second one we did was y minus y1 is equal to m times x minus x1. We did this one also. It is known as point slope form. We did both of these. It's up to you. These both are equation of, the line. These both are equation of the line. Whichever you want to do. Which one you want to use?
The first one.
Okay, you want to use the first
mx
one.
plus b.
Okay, so what's my m? What's my slope?
For what number?
For this one. For this problem I'm talking about.
Oh, sorry.
What's my slope? Note we checked. Right now we checked, right?
Yes.
What we were checking. What is this? What is -3 I'm finding? What is this -3?
The slope?
Yes. So I know my slope is -3. I just found right now. -3x. What's my b? In this equation, what is my b in this formula? My m is my slope, my b is my?
Y-intercept.
Yeah, it's a y-intercept. Am I given the y-intercept here, Giselle?
The what, excuse me?
Is my y-intercept given here or no?
No.
How do you write
Yes.
y-intercept is 0,
Yeah.
comma b?
Yeah,
right?
it is.
It's given already there. Y-intercept is 0, comma b. Is 0, comma b here?
-2.
Yes, perfect. So your fx becomes -3x, -2. Perfect. Any doubt with this problem here?
Yeah.
If you have book, I want you to do problem number 22. I want everyone to do problem number 22. If you have the book. Problem number 22. So basically you have x and y. You're given -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4. I want you to find check whether this is linear. If it's linear, I want you to find the equation. You go.
Yeah.
Yeah, you're gonna solve these 2 points and tell me what's the slope you're getting.
So what I did is I subtracted 4 minus 2 over 2 minus 1.
So you're saying formula is y2
No,
over x2 minus x1, right? This is my y, that's my x. So what's my y2?
Yeah. So I start with the bottom numbers. So 2 x1 and y2 and 2 x2 and
what's my
y.
x2? Okay, let me write like points like this so it's clear. -2, 1, 4 and -1, 5, -1, 1/2. Okay, I'm gonna write it like this so it's easy.
Okay.
So you tell me what's my x2?
The x2 is gonna be -1.
Okay, saying -1 minus, and what's my x1?
+2 or parentheses -2.
Perfect. And what's my y2?
Your y2 is gonna be 1/2.
Yeah, 1/2 minus
1/4.
1/4. Okay, let's solve it. 1/2 minus 1/4, what is it?
Just a second.
Can I subtract directly, Hugo?
No, you can't. You have to make a half common denominator. So what I'm gonna do is multiply.
Multiply with
Yeah, times 2.
2. Just here, or I'm going to multiply numerator also with 2.
Oh, would it be? Yeah, multiply that times 2. Is that fine?
Yeah.
Okay, so it's 2/4.
Minus 1/4. At the bottom, what does it become? -1?
Now it's +2.
Positive 2. Okay. What is 2/4 minus 1/4?
1/4
1/4. Divided by?
divided by 1.
Which is equal to?
Just a second. So
What is anything divided by 1?
it's itself 1/4.
1/4. So basically you got your answer as 1/4.
Yeah.
Okay, perfect. Was?
Yes.
Okay, when I do these two, what do I get my slope? I'm using -1, 1/2, and I'm using 0, 1.
Slope's gonna be
What's my y2?
1.
So you're saying 1 minus,
1 minus 1/2.
okay, over, what's my x2?
0.
0 minus,
-1.
okay, so what does it become? What is 1 minus half?
1/2.
Yeah, 1/2, perfect. And what is 0 minus -1?
+1.
So which is equal to?
1.
Final answer, final answer.
1/2.
1/2. So when you're doing these 2 points, you're getting 1/2. Not in, before doing these 2 points, I was getting 1/4. I'm taking the next 2 points, I'm getting 1/2. You don't have to check for other points. Your directly answer is, it is not linear. You don't even have to check for other points. Directly you say it's not linear, because I found 2 points where my slope is not equal. Any doubt with these kind of problems? Okay. Next thing we're gonna do is, let's see. Distinguish between linear and non-linear functions. So I'm on page number 142 if you have your book. If you have your book, I'm on page 142. Okay. So it distinguishes between linear and non-linear relations. If all my points are somehow making a straight line, I want exactly the straight line, then they are linear. See, in this case, all my points, if I see, they're actually making a straight line. So this is a linear function. In this case, all my points are still in a straight line. They're all in a straight line. It's still a linear function. But in this case, if you see, they're making this curve. It's not a straight line, so it is non-linear. Even in this case, see, they are making a, this kind of, this is not a straight line. It's non-linear. Even here, it looks like linear, it looks straight, but it's not straight. It's going curved like this. This is not linear. So how do you check if given a diagram, you have to check linear or non-linear? You have to just check for a straight line. You just have to check for a straight line. If it's a straight line, it's linear. If it's not a straight line, it's not linear. It's easy like this. So if we do these examples here, to check whether it's linear or not, okay. Can I have Miguel, Joshua?
Yep.
Can you tell me, is the first one linear?
Which one?
This one.
It looks linear.
Yeah, because it's a straight line. Yes. Alejandro?
Yes.
If this one is a linear or no? The B one. Alejandro, is this one my linear?
It's not.
It's not, because it's not a straight line. Perfect. Gerald?
Are we looking at C now?
C, yes.
Yeah, that one is non-linear.
That's non-linear because it's not a straight line. Perfect. Jelena? Let's see his answer. Perfect. Jelena? She's not a Carly.
Yes.
The fourth one.
The fourth one, I would say is not linear.
Why is not linear?
It looks like it's like bending or something.
It's bending. It's not a straight line.
Yeah.
So from section 3.2, we are just doing this. We are not doing any applications for section 3.2. So here today we are done with section 3.1 and 3.2. But I'll start a little bit of section 3.3. So since we have time, I'm going to start section 3.3. Section 3.3. Okay. What does it say is quadratic? Quadratic function. The general form of quadratic function, how does it look like is, it's fx is equal to ax square plus bx plus c, where a, b, c can be any real number. There can be any number, my a, b, c. But there is one condition. My a cannot be equal to 0. That's the only condition. My a, b, c can be any numbers, but my a cannot be equal to 0. Yeah. Also, you can write note. I'm going to explain this why. Domain of quadratic function is all real numbers, or you can say negative infinity to infinity. Negative infinity to infinity. Why it cannot be equal to 0? So suppose first let me give you examples. I give examples. I take a as 3x squared plus 2x plus 5. That's example. I can take example as 3x squared plus 5. Just 5. I'm not taking 2x. Why I'm not taking 2x? Because I can write it as 3x squared plus 0x plus 5. So 0x, I remove that 0 because 0 times anything is 0. So I basically get this thing. I can have that thing also. I can have just 3x square also. Note, but my a term, the term with the x square cannot be 0. If I write fx square is equal to 0x square plus 2x plus 5. If I write like this, this basically becomes 2x plus 5. Note this is not quadratic. This is not quadratic because it became linear. It became linear. We've been doing it became of the form mx plus b, which we've been doing. It became in the linear form. So it does not remain quadratic anymore. So this is your a cannot be equal to 0. A cannot be 0. Note in this, okay, if they give you problem like this, say solve the quadratic, you cannot solve if your a is 0. That becomes a linear function. Okay. Any doubt with this example? Okay. Next thing what they want you to do is, next thing, so this thing is very important. Make sure you understand this concept here. It says they want you to graph the quadratic function. Graph the quadratic function. So they will give you something as fx is equal to 2x square plus 8x plus 5. They want you to graph this. They want you to graph this using two things: vertex and axis of symmetry. What are these things? Vertex and axis of symmetry. Okay. Let me explain this. This in 3 for a second. 4, 6 is 5. How do you do it is, there are two ways of finding vertex. There is two ways. Rather than telling you the two ways, I'll tell you the easy way. I mean, there is one more way. I'll explain that. But the easiest way is using the formula. First, figure out what's your A, what's your B, and what's your C. I want you to figure out what's your A, what's your B, and what's your C. Christopher, what's your A in this example?
A is 2.
B is?
B is 8.
And C is?
C is 5.
Okay, you found this thing. Perfect. What you're going to do is you have to find your vertex. So how does your graph look like for quadratic is? How does your graph look like is? It looks something like this. It looks something like this. The graph looks something like this. It can look like this also, downward facing. It could look something like this, downward facing also. The point where it changes from decreasing to increasing or increasing to decreasing, that is known as vertex. So this point here is known as vertex. So they want you to find the vertex. The easiest formula to find the vertex is, put in the formula. The formula is minus b over 2a comma f of minus b over 2a. Very important formula. Remember this. For vertex, the formula is minus b over 2a, and then how do you find the y is whatever x you find, put it in the equation here and find the y value. I'll do an example. Let's do an example. Okay. So can I have Joshua?
Yep.
Let's find first minus b over 2a. What is minus? What's your b?
8. So we negative 8 over
2 times?
2 times 2 equals 4.
Yeah, which is negative 8 over 4, which is?
Negative 2.
Negative 2. So you found one point as negative 2. Now I have to find basically f of negative 2. How do I find my f of negative 2, Joshua?
You would plug it in?
Yeah, plug it in. Plug it in the original equation. Yes, what does it become?
We put into the original equation, right?
Yeah, original equation, yes. It will be 2 times
2 times, or be negative 2 times negative 2. To be 4 times 2 is 8.
8 times negative 2
16
and plus
is
5.
negative 8. 8 plus 5 is negative 3.
Okay, so what does it become? What does this become? You tell me. What is 2 times negative 2 square?
Negative 16 or 16.
2 times, what is negative 2 square?
4.
Okay. Plus, what is 8 times negative 2?
8 times negative 2. Negative 16.
Negative 16 plus 5. What is 4 times 2?
8.
8. Negative 16 plus 5. What is 8 minus 16?
Negative 8.
Negative 8 plus 5, which is equal to?
Negative 3.
Negative 3. So that's how you found your point. Negative 2, negative 3. Any doubt how to find the vertex? So first you're going to find minus b over 2a. Once you found your negative b over 2a, you're going to plug this negative b over 2a, whatever you found, in your original equation. In your original equation. That's how you find your vertex. That's how you find your vertex. And you know, there is another thing. There is another thing for graphing. What you can do is look at your A. Look at your A. Look at A. If A is greater than 0, if A is greater than 0, this thing parabola will always face upward. My graph will always look like this. So that's how you can check. If A is negative, my graph will always be facing downward. So that's one way of checking also. And you know what is your axis of symmetry? Axis of symmetry. Axis of symmetry will always be equal, that will always be x is equal to negative b over 2a. That's your axis of symmetry. So we already found our negative b over 2a, which was negative 2. So axis of symmetry is x is equal to negative 2. Now how to graph this? Let's see how do we do the graphing part for this one. I want everyone to graph this. Let's see. Since we found these 3 points, we can do it. It's very easy to do it. Let's see.
Can't hear you.
Oh, I'm right now just graphing
Yeah,
right
yeah,
now.
yeah. It's going back in. Just that you have an iPhone or something, right? Because they keep on hearing the charging cable.
Oh yeah, I guess it's a charging thing. It's plugging up. I got it. Okay, let's graph it now. Okay, so we found our vertex as negative 2, negative 3, and then we found my A was greater than 0 because A was 2. A was 2, so that means it will look something like upward facing. And then I found my axis of symmetry, which was x is equal to negative 2. So these are the things I found. These are the things I found. So let's see. So this is my 1, 2, 3, 4, 5, 6, 7, and this is my negative 1, negative 2, negative 3, negative 4, negative 5, 6, 1, 2, 3, 4, negative 1, negative 2, negative 3. So can I have Axel?
Yes.
Okay, I want to mark this point, negative 2, negative 3. Can you help me mark this point, negative 2, negative 3?
No, pardon?
I want to plot this point, negative 2, negative 3. Where is my point, negative 2, negative 3?
It's two to the left and 3 down, no?
Yep, 2 to left, 3 down. So it's this point here. Perfect. This is my negative 2, negative 3. So this is my vertex. This is my vertex. And I know it's upward facing, so it's going to be something like this. My axis of symmetry. Axis of symmetry is x is equal to negative 2. How do I draw axis of symmetry is? So let's draw a table. Axis of symmetry will always be a straight line. It's going to be a straight line. it says my x is equal to negative 2. No matter what my y is, since my y is not there, my x will always remain negative 2. I take y as 0, I take y as 1, I take y as 2. Okay. So this is your point. You're saying it's gonna be upward facing. Axis of symmetry. What is this axis of symmetry is? It's not a part of the graph. It's actually, the graph is just this thing. Your graph looks like this, but axis of symmetry tells me, so this is my axis of symmetry. It will cross this vertex here. It will always cross this vertex here at this point. But what's the reason of having axis of symmetry is because it divides my graph exactly into two parts. It acts like a mirror. Whatever is on this side, we'll have the same thing on the other side of the graph also. My one side of the graph will also look like on the other side. So axis of symmetry, basically my graph is symmetry on both sides of the axis of symmetry. And you always draw the axis of symmetry as a dotted line. So let's say x is equal to negative 2. 0, negative 2, it's going to be this point, 1, 2, this point, and this point. So basically, and you draw axis of symmetry as always a dotted line. But since they're asking you to use just these three vertex axis of symmetry, so you know how your graph, it will cross at the vertex, so it will go something like this. Since they are asking you to just use this thing, use just that thing and figure it out. That's it. You knew it's gonna be upward facing because your A was positive. You found your vertex, you found your axis of symmetry. Whatever is on this side, my graph will look exactly the other side, the same thing. Any doubt with these three parts? Vertex, figuring out how your graph is going to look, and then axis of symmetry. Okay. How do I find y-intercept? I want to find y-intercept also for graphing now. I want to make my graph more accurate. This is just my exam. I'm assuming it was going to look like this. I want to find my y-intercept. What's the condition for y-intercept?
When x equals 0?
Yes, we know x is equal to 0 in y-intercept. So in the equation, main equation, put x is equal to 0. Put x is equal to 0. So your original equation was this thing, 2x squared plus 8x plus 5. This was what we were graphing. So put your x is equal to 0. So you're given fx is equal to 2x squared plus 8x plus 5. This is what we are graphing. Put x is equal to 0. What does it become? Y is equal to 2 times 0 square plus 8 times 0 plus 5, which becomes y is equal to 5. So 0, 5 is your y-intercept. So note my graph is not that accurate here. My graph was supposed to cross this point here. So it's going to go like this and go up here. Any doubt with y-intercept? Let's see the x-intercept now. This is very interesting, this x-intercept. How do you find the x-intercept? That's the only tricky part in this quadratic. Everything else is very easy, but if it is just this thing, which is going to be tricky. So how do you find your x-intercept is, how you're going to do it is, there is two formulas, there's this formula, and this formula throughout the book you'll be using this formula very, very, very often, this formula. So memorize this formula. It is minus b plus minus root of b square minus 4ac over 2a. It's this formula for x-intercept. You will be using this formula very, very often. So make sure you memorize this formula. Throughout this book, this formula is used like so many times. In each and every chapter from now on, you're going to use this formula for x-intercept. So plug in your x, a, b and c. We knew yeah, A is here 2, B is 8 and C is 5. Plug in here. So it becomes negative 8 plus minus square root of 8 square minus 4. A is 2 and C is 5 over 2 times 2, which is equal to x negative 8. First, always solve inside the square root. First, always exponent 8 square, which is 64. Then you have negative 4 times 2, which is negative 8 times 5 over 2 times 2 is 4. Let's solve it again. Negative 8 plus minus square root of 64 minus 8 times 5, 40 over 4. Anyone who's having trouble with this problem here? This thing is very important here, what we are doing. Then you do the subtraction. Let's do the subtraction here. So you got as negative 8 plus minus square root of 64 minus 40 over 4. That's what you got. Let's solve this. So it becomes negative 8 plus minus square root of 24 over 4. You're like, I don't know the square root of 64. I don't know the square root of 24. Use a calculator and tell me what's the square root of 24. So negative 8 plus minus, it will be in decimals. Tell me, anyone, use a calculator and tell me what you are getting. Square root of 24.
I got 4.898979.486.
8, 9. So let's say take up to 2 decimal places. 8, 9 and then you got 8, right?
898, yeah.
898 you got here. So divided by 4. You got this thing. So basically, if I'm saying you have to take up to 2 decimal places, it will tell you in the question. On MyLab, it will tell you up to what decimal places they want. So it basically becomes 4 point, if I take up to 2 decimal places, becomes 4.9 divided by 4. So your x first, so let's subtract this, separate the signs. First I use the addition sign. Then I use my subtraction sign. And then solve. So you get what you get, negative 8 plus 4 by 9.
Uh, 3.1 over 4.
Yes, negative 3.1 over 4. And what do you get here? And then you divide it. You'll get negative in decimals. Always get in decimals because we are plotting. You will not figure out where to plot unless you have the decimals. So it becomes negative 0.7
0.75, I'm going to guess.
Yes. Yeah, it's going to be 7.5. Yes. What about here? It becomes negative 3.22. So these are your x-intercepts. You found your x-intercepts also. You have your x-intercept. You have your y-intercepts. We're going to do all this in detail. Don't worry. Tomorrow I'm going to give you a lot of examples on this. I know I rushed into this one. The x-intercept. X-intercept is very important in quadratic. I'm going to go over again tomorrow. But this is how we do it. I'm going to go over quadratic section 3.3 again tomorrow. Don't worry, okay? I know it was too much for quadratic, but yes. Any doubt so far? This is your x-intercept. So minus 0.750. This is your x-intercept, and negative 3.22, 0. That's another x-intercept.
We'll do more tomorrow. Is that okay?
Yeah, we'll be doing this tomorrow. We'll be doing this tomorrow in detail. Any doubts so far in today's lecture? Okay. I'll be assigning homework for today. So make sure you start doing that also. It will be related to section 3.1 and 3.2. 3.3 won't be included. 3.3 we'll be doing tomorrow. I'll be doing this all over again. How to find x-intercepts. Thanks guys, but I want 2 people to stay behind. Hugo, and I want 3 people. Hugo, Giselle, Carly. That's it. And everyone can go. Have a nice day, guys. Thank you.
Have a good day.
You have a good day. Bye.
I had a question.
Yes.
For the exams, are we gonna be expected to know how to use the scatter plot?
Which one?
For the exams, are we gonna be expected to know how to use the scatter plot?
No.
Okay.
No.
Are you gonna also do the reflections and transitions?
No.
Okay. And there was something else, but I forgot. No, I'm fine. Thank you.
Yeah, sure. Let me know if you just message me if you figure out, okay?
All right. Thank you.
Perfect. Yeah, sure. Okay. Hugo.
Yes, I'm here.
Hugo, Giselle, and Carly. You 3 did not take the quiz. Why?
Oh, I had trouble.
Okay, Hugo.
I totally forgot about it, honestly. I tried, I remembered on Friday before going to work and it was blocked.
Yeah, so you guys, you're missing the quiz. Quiz is very important. You know that it's going to affect your grade.
Yeah, mostly because it's the first quiz. But I
Yes.
totally forgot about
And
it.
trust me, this thing right now, what we are doing basically was the revision part. And it was easier. It's just going to get tougher and tougher from now on. You're
Okay.
seeing as we are going to formulas now. And these formulas, I mean, quadratic is not easy. Linear till linear, it was easy part. As soon as we're going to go quadratic, then polynomials, it's just going to get tougher and tougher. So make sure, you're taking your quiz. Initial quizzes are very important. You missed this one, that's okay, but I want you to do it. And what about the homework, Giselle? I've not seen your homework either.
My homework on my lab,
Yes.
I've been doing it. Our 4 subjects are, 2 of them have 97%.
Oh,
The other
okay.
one I'm still in progress, 2 of them.
Okay, then maybe
One of them it's 97, I believe, 2 of them, 78, and the other one is 69, I believe.